I'm going to show a demo of the Tock blinking app, which will show in the virtual environment QEMU, so no hardware needed, but this could easily be run on one of the embedded platforms supported by Tock. So the app that we're going to run for the demo will be LED simulation of LED lights blinking in a counting sequence. So the first thing to do is to set up the environment. So you can set it up on Windows, Mac, or Linux. I set it up on Linux Ubuntu 24, and so that'll be what I run the demo from. But the two resources they use, the Talkbook, has instructions for multiple operating systems, and then also I have some gist notes of my own, and this was on the Ubuntu 2404. So to set up, can follow, so go to this website and then find the operating system you're going to need and select that. So they have Ubuntu or Mac, Ubuntu, and Windows. The main idea here is setting up Rust and then setting up the repositories and Tock Loader, which you had talked about, which will do the maintenance. Can do it this way. I'm going to show also in my notes a way with UV and then installing QEMU. The way, just to show in the notes that I have for doing this, this was just setting up from a base Ubuntu environment with OpenSSH to be able to log in, setting up some of the tools that might be needed for Ubuntu, and then the Rust tool chain. So that was similar to the on the Talkbook. And then I used UV for installing Python. And then this is just the directory structure I set up. I use the recursive flag. It's not necessary, but I use that for, and then I just went ahead and installed the two example libraries and then Tock. And with that, there's also for the QEMU, these are just the notes of setting up a QEMU board. And then this would be if you're using an actual embedded board, so you can skip this step of not using an actual embedded board, which we're not for here. So going back to the book, once setting this up, then it's a matter of compiling the kernel, which going into the Tock repository, and then running these instructions in the QEMU tutorial directory. And once we've done that, we'll be able to then see the LED blinking. And then, or actually, so this would show up without the app installed, so there wouldn't be any blinking when this is run. And then installing the actual app would be cloning this repository and then building the app, which I will show here. So I'm going to assume their kernel's already built, and then go to here. This is in that kernel directory, so in the where the tutorial is, and then this is in the repository with the example code. And so we're going to build that Blink app, and if you look in Visual Studio Code, so this is the libtock RS repository. This will be the app that we build, so Blink RS, and you can see that it uses no stud, it uses no main, and then it's using some of the capsules for the LEDs and then the alarms for triggering timing. And the code is basically running the counting, so gets the number of LEDs available on the board, or QEMU as 4, and then it goes through the counting sequence of turning them on and off individually, and then sleeping for a quarter of a second, and then just looping through that. So that'll be the code that we compile. So if we go back to our book, and I'm going to start with, so assume that the QEMU is set up and the kernel's compiled. So we'll first build the Blink app, and this tab is the type of file to the Tock file to make for the executable, and then just saying the example Blink. And so if we go here, and I'll just go back up to, oh, actually, we'll use Tock Loader to first to list what applications are on the board. And so I already have Blink on there. So I'm going to erase the Blink app, which is erase apps. And then if we do a list, you can see that there's no apps found on our virtual QEMU board. So that's, now if we want to build this, go back to here, and then I'll copy that and paste it. And we can go through. It's going to build for different processors and different memory locations too, because of the non-relocatability of the older LLVM. And so it makes a bunch of those. And then when we go to install it with the Tock install, so if we go back to here after building it, use Tock Loader install. Oh, and one thing is I have a Python virtual environment that when I did the Tock Loader install, I created the Python virtual environment, and that's what's being run right here, so that I can have that version of Python separated from what I normally use. And all we need to do is that Tock Loader install, and it will automatically find the right board file. So it found the kernel right here, the kernel board, and then it's looking and it gets the app Blink and then the flash location, which I think will be one of 810. And I think that would be, let's see, one of these RAM locations. But I'm not seeing that off the top of my head. It might just be the location 2000. We can revisit that. But oh, actually, I think like one of these files. So it's going to choose the app that's one of the files that it's built at the different locations, and that's the one it chose to install it. And then that's the base of memory where initially installed it. And then if we go back to the book, so we can then list and make sure that we actually see it. So if we here, and we can see that it's installed. So we have one app, and it's the Blink app. And then we can go and actually run it. So here we're going to go back to the Tock repository directory, so the boards directory that you'd run the build and everything in. In this case, we're just going to do the make run. So make run, and this will build this. This is going to install it, and we can see that now this is the emulated board. And there's some kind of fun stuff here, and so you can see this is the counting sequence, so the 4 LEDs doing the counting sequence that is shown right here in this code. And one of the nice things to do is because Tock has, for its kernel, we're in the kernel loop, and we can type help, and we can list the processes. And so this Blink process right here, we can actually stop it. And this would be the same as if on an actual board. So this really makes debugging a lot easier. I'll say stop Blink, give it the name, and we can see that stops. And then we can use start Blink to start the process. So say start Blink. And we've now started the LEDs blinking again. So you can also look at the status, and there's a lot of other details that we'll be using more of, but this is kind of a nice way to do it. And when you're done, you can just, if you close the QEMU, it will exit that, and you're back at the terminal.